Welcome back. So if you're building a scalable MERN application, the database layer is, well, it's everything. It's the foundation.
Absolutely.
Today we're diving into the source material to figure out the fastest way to really master MongoDB and the critical art of data modeling.
Right, and MongoDB is that high-performance, document-oriented engine that makes the MERN stack so incredibly fast.
It really is.
Its superpower, really, is that it stores data as BSON.
Yeah.
And BSON is just the binary version of JSON.
That seamless flow is the whole game. I mean, React and Node are speaking JavaScript objects, which is basically JSON.
Exactly.
So because BSON is JSON's binary twin, there is literally zero data format conversion needed. None.
And that saves so much complexity. The speed gain is immense.
For a quick reminder on architecture, MongoDB organizes data into a database, which holds collections, sort of like tables.
Right.
And those are filled with documents, which are your actual JSON records.
We all love MongoDB's flexibility, but, that flexibility can easily lead to chaos.
Oh, for sure.
Which is why we need structure. And that structure is data modeling. It's about designing how your documents relate to each other before you store them, just to guarantee performance.
And the source material confirms MongoDB handles all the relationships you're used to, right? There's one-to-one, like for a user profile.
Yeah, one-to-one.
They have one-to-many, say, a user and all their blog posts. And, of course, many-to-many, like students enrolling in courses.
But the crucial choice, the one every MERN developer has to make, is embedding versus referencing.
Okay, so this is the real fork in the road.
This is it. Embedding means you're putting related data directly inside the parent document.
So if embedding gives us these blazing fast single query reads, why on earth would we ever bother with referencing?
Because you can't embed the entire library. I mean, think about an e-commerce order. You would embed the customer's shipping address. It's small, it's static data.
Right.
But you would reference the entire product catalog of 1 million items by just storing their IDs.
Okay, that makes perfect sense.
Referencing avoids storing massive chunks of data, and it completely eliminates duplication. It's essential for large or volatile data. I once spent, I think it was 2 days, debugging an app, only to realize I'd over-embedded a history log with millions of entries into one user document.
Well,
It was a rough lesson. You really have to choose based on the size and the access pattern of the data.
so once we've modeled those relationships, how do we enforce the rules and prevent junk data from getting into our node server?
And that's the perfect transition to Mongoose. See, MongoDB is naturally schemaless. You can store anything, anywhere.
Right.
Mongoose, which is an object data modeling library, or ODM, is basically the structure police.
Okay, I like that, the structure police.
It lets us interact with the database using normal JavaScript objects, and crucially, it provides schema definition and data validation.
And that validation is just key. Mongoose schemas make sure that the documents coming in are clean, they enforce data types, it prevents so many bugs.
It simplifies the CRU'd operations. Create, read, update, delete that, every single backend needs.
So even with Mongoose, the source highlights that beginners still fall into some common traps.
They do. The big one is still poor data modeling, usually over-embedding large data, and failing to validate data is another.
Okay.
But the third major mistake is ignoring indexing. MongoDB relies on indexes, think of them like signposts, to navigate massive collections quickly. If you don't index the fields you query a lot, performance just grinds to a halt.
So to wrap it all up for you, MongoDB gives you that incredible speed and flexibility. But it's that combination of thoughtful data modeling and enforcing structure with a tool like Mongoose that makes an application truly scalable.
Exactly. Good modeling prevents bugs, it increases speed, and indexing is just essential for large systems. So the question for you to consider is this. If you were building a massive, flexible data store, say an e-commerce site handling millions of orders, where is that trade-off point? Where does optimizing read speeds with complex indexing become more important than the development flexibility that NoSQL is so famous for?
Something to mull over. Next time, we're moving up the stack to cover REST APIs with Express, controllers, and how to build a clean backend architecture. Goodbye for now.